Hello students, let's go to the next topic of our syllabus. That is nothing but a angle of contact today we have to see. So before going into detail, as its name suggests that it is angle of contact. It was represented by the letter theta. So angle of contact means what? When the liquid comes in contact with the solid, when the liquid comes in contact with the solid, the liquid at a point of interface makes some contact with the liquid, and if that angle is measured inside the liquid, then that is said to be angle of contact. I know that you didn't get anything. Don't worry, I will tell you. Suppose this we have taken as a first liquid. So this is one beaker. In this beaker, this another tube we have placed, that is said to be capillary tube. When capillary tube was kept in this water, suppose this is water we have taken, in the water we have kept this capillary tube. It is surprising that it is seen that in under the microscope, the water level in the beaker is up to this. But in the capillary, this water rises to certain height. So this height, the water rises in the capillary tube. And this rise in the level of water, that we'll see in the next subsequent topic. Our aim is here, this thing get formed. Now if you see here, it is not horizontal, it is little bit concave part. Concave part, it is said to be meniscus. So it is nothing but a meniscus. So this meniscus is concave here. At the same time, if you see the second diagram, here it is mercury. Instead of water as a liquid, we have taken a mercury as a liquid. Same tube we have kept. It is seen that instead of rising the level, it get fall. It get fall by some height. This is the height by which the liquid level get decreases. How it get, that we'll see in next topic. So here the shape, if you see this shape inside the capillary, the shape of the liquid is nothing but what? It is nothing but a convex part. So here in case of mercury it is convex, in case of water it is concave part. Now what is the angle of contact? If we draw the tangent to the surface at point of contact, so here in this case this is the point of contact. This one, second point of contact, third point of contact, fourth point of contact. So if we draw the tangent to the liquid surface at a point of contact between liquid and the solid, here suppose I will draw the tangent here. So we can draw the tangent like this. So I have drawn this tangent like this inside the liquid. Then the angle measured between the tangent drawn to the liquid surface at a point of contact measured inside the liquid. So this is inside the liquid. So this angle is theta, and that is said to be angle of contact. Remember, don't measure the angle outside like this. So angle must be measured inside the liquid, and that angle is said to be angle of contact. This angle of contact we have seen in case of water and glass. Here, angle of contact, we have to draw the tangent to the free surface of the liquid. So this is a point of interface 1, interface 2, 3, 4, 5 and 6. So let's draw a tangent here. So we will draw the tangent like this. Suppose this is the tangent I have drawn, and angle measured inside is this. So angle measured inside the liquid in this case is this, and this is the tangent. It will make angle this. This angle is said to be theta. That is said to be angle of contact. I hope that you get idea about what is meant by angle of contact. At a point of interface between liquid and solid, tangent drawn to the free surface of the liquid, then angle between tangent measured inside the liquid is said to be angle of contact. Now here angle of contact may be acute, may be obtuse, maybe 90 degree, maybe 0 degree, depending on which liquid we have taken. If you take glass, this meniscus becomes concave in glass and water. Here if you take glass and mercury, the meniscus become convex part. So this change as liquid get changed, or liquid and the pair of solid liquid get changed, this meniscus shape may get changed. It may be concave or it may be convex. So let's start with this. The next topic of the same topic is nothing but we have to give the different shape of meniscus and how the angle of contact can be measured with a different pair of solid and liquid. And when it becomes less than 90, it is said to be acute. When it is greater than 90 degree, it is said to be obtuse. When it will be 0, and when it will be taken as 90 degree, that we have to consider. For that I have drawn here side by some figure I have drawn. Let's go to that figures and let's start with that topic. So if you see here, I have drawn the 4 figures. So out of that, first of all, let's see the first 2 figures. So the first figure, it shows here angle of contact is acute. Acute angle of contact. Acute means the angle must be less than 90 degrees. So if you see this figure, in this case concave meniscus, concave means this is concave part, and then the angle of contact is theta is acute. Acute means theta must be less than 90 degrees. So let's start with this. So what I have done, so this square I have drawn here, or this rectangle I have drawn here, it is nothing but a solid. I have mentioned it as solid. And here, this surface and bottom surface I have not drawn. Just one side I have drawn, and this is nothing but a beaker, and this one side of the beaker, which is a glass, it is solid. And in this I have kept some liquid. So this liquid I have kept. Okay. Apart from this, this is a point of contact. This is surface, and this point of contact, that is A. Okay. At this A, you can draw the tangent to the liquid surface, and that comes here AT. AT is tangent drawn to the liquid surface. So angle measured inside the liquid between tangent and the solid surface, this angle is theta. That is said to be angle of contact here. Okay. Apart from this, here there are different forces act on the molecule A. Different forces, intermolecular forces, as we have learned. So intermolecular forces are what? Cohesive or adhesive. Cohesive forces between the molecule of same liquid. Adhesive forces are nothing but forces between molecule of different material or different surfaces. So let's see, here there are two surfaces, solid and liquid. So this AC, this line AC represent the force, cohesive force. C for cohesive force. AC represent the cohesive force exerted by liquid molecule on a molecule A. AC represent the cohesive force exerted by liquid molecule, remaining liquid molecule on this molecule A. At the same time, this AP is the adhesive force. The AP, this vector AP or arrow AP represent adhesive force exerted by remaining solid molecule on molecule A. So adhesive means what? A must be water. It is water and these are solid. So there are different force between the two different molecules. That is adhesive force represented by AP. AC, A is a water molecule or liquid suppose, and this remaining liquid molecule exerts some force. That is AC is cohesive force, AP is adhesive force. And in this situation, it is seen that within this diagram, if you see, if you draw the resultant of the forces, resultant of force AC and AP, and that was represented by the arrow AR. AR is said to be resultant. In this situation, the adhesive forces AP are so much stronger than the cohesive forces. So we can say adhesive force is very much stronger than the cohesive force. That's why the resultant of these forces goes completely in the solid. So this resultant comes in a solid. Means what? Adhesive forces are greater than the cohesive forces. And this is the first situation. Here, if solid we can consider as a glass and liquid we can consider as a kerosene. Kerosene they have taken in a book. So kerosene and glass pair if you take, solid liquid pair if you take, it is seen that the adhesive forces are stronger than the cohesive. Resultant force is shifted in the solid. That's why this liquid rises. See, this is normal level. A must come here, but it's not coming here. It goes a little bit up because the adhesive forces are stronger. And that is the situation. And if you measure here this theta is always less than 90 degree, and that is said to be acute angle. And the meniscus, this meniscus shape has become what? It is a concave shape. So that is nothing but a, so we can draw it this as a convex shape, concave shape. So if you raise it like this, and this is the other edge. So concave meniscus get formed, meniscus get formed. At the same time, the adhesive forces are stronger than the cohesive. So angle of contact is acute angle always less than 90 degree. So this is the first part that we have seen now. Now let's go to convex meniscus. Convex meniscus means what? The instead of this kerosene, here they have taken kerosene. Here this liquid they have taken a mercury. Just already we have told you, I have told you initially, mercury make a shape like this. It get like this. This again a solid. This is a mercury liquid. Okay. Now here again the point of contact comes here. Level rises, but point of contact is close here at a little bit lower height. So this point of contact is A. If we draw the tangent to this liquid surface, it goes upward like this. Because it is convex part, it goes upward. And this angle measured in the liquid is nothing but the angle of contact theta. And it is seen, it is common sense from this diagram. This theta is found to be greater than 90 degree. If it is greater than 90 degree, it is said to be obtuse angle. And this meniscus get formed. If you draw it here, it come like this. So this meniscus get formed is nothing but a convex meniscus. Okay, and here again the cohesive forces represented by AC, adhesive forces represented by AP. Cohesive forces AC means what? Mercury molecule exert a force of attraction on a molecule A. Both are same, made up of mercury, so that cohesive force. The Mercury molecule exerted by the force by remaining solid molecule. Molecules are different. That is nothing but a adhesive force. Here again, it is seen that the forces exerted by remaining liquid molecule on a molecule are very much stronger than the adhesive forces. Cohesive forces are stronger than the adhesive forces. That's why this resultant AR shifted inside the liquid. So this AR is shifted in the liquid because cohesive forces are stronger. Here adhesive forces are stronger, that's why shifted to solid. Cohesive forces are stronger, that's why they shifted to liquid. Resultant AR shifted to liquid. That means cohesive forces are stronger than the adhesive forces. The angle of contact theta is said to be obtuse angle, and convex part of meniscus we found. We found the convex part of meniscus, that is theta is obtuse. That is nothing but a second figure, and that is example of glass and mercury, example of glass and kerosene. Now let's go to third diagram. If we see, this is third diagram, I have drawn it here. This is what zero angle of contact. Zero angle of contact is possible with certain liquid. Suppose we have taken a pure water. So this is suppose pure liquid, nothing but what? Water, not an ordinary, it is pure water. Pure water in contact with a pure glass. This is again pure glass. There is no impurity. So this is solid liquid pure glass and pure water we have taken. In this situation, this A is a molecule here. Now remember, the adhesive forces acting on this molecule A are so stronger that directly you can write this AP as nothing but the adhesive forces, and this AP itself has nothing but the resultant AR. Cohesive forces are negligible in this case. If you take a pure water with a pure glass, the cohesive forces are negligible and adhesive forces are very strong, so that we can write here AP equal to AR. AP for adhesive forces, and that itself is nothing but a resultant, that you can say that you can get the idea that how much strong these adhesive forces are. And that's why you find out angle of contact here, it is exactly parallel to the surface. If they are parallel to surface, theta equal to 0, and that is said to be angle of contact is 0 for such a pair, just like a pure water and pure glass. Let's go to fourth diagram. I have drawn it here. If you see here, angle of contact is 90 degree. There are certain liquids, I have not drawn the liquids here. There are certain liquids, some liquids are such that in that case the cohesive forces represented by AC again, adhesive forces represented by AP again, the resultant comes exactly parallel to the solid surface, AR. Then we can say here angle of contact is 90 degree. So if you measure it here, it comes to be 90 degree. So this such type of liquids are there. So this would be the angle of contact, and this comes to be 90 degree. So 90 degree angle of contact get found in such type of solid liquid pair. And here, apart from this, we have seen this part. Apart from this part, one point I have forget to tell you. Let's revise that point. In first case, the adhesive forces are stronger than the cohesive force. The glass and kerosene, such type of liquid, weight the solid. When we put such a liquid in the beaker, it will weight the solid. If you put such type of liquid, just like a mercury in glass, it cannot weight the solid because cohesive forces are very strong. It cannot weight the solid. And here in this case, angle of contact is already 0. Here this angle of contact is 90 degrees. Apart from this, just they have mentioned in the book, there is one diagram. Same diagram, they have mentioned angle of contact is 90 degree. They have given some conditions. When the angle of contact would be acute, when it will be obtuse, and when it will be 90 degree. For that they have derived some condition. So I will write one condition here. Angle of contact is 90 when AC and AP are related by one equation. AP equal to AC divided by root 2. So this AP equal to, so they have not shown, just we can show arrow, or you can show the arrows. So this AP equal to AC by root 2. If this gets solved, or if such condition gets satisfied, angle of contact is 100%, it is 90 degree. So if AP equal to AC by root 2, angle of contact is 90 degree. Apart from this, if AP is greater than AC by root 2, this second condition, AP is greater than AC by root 2, angle of contact is said to be acute. In this case, angle of contact is acute. Angle of contact is acute because here AC is less than AP. So angle of contact is said to be acute one. And opposite to this, if AP is next one less than AC by root 2, angle of contact is obtuse. So these are the condition when the angle of contact is obtuse and angle of contact is acute. So these things we have learned. Now let's go to next topic, the shape of liquid drop on solid surface. So what exactly shape of liquid drops on solid surface? When we draw the surface, any surface if we take and we have put some liquid drop on that surface, it is seen that either drop acquired a spherical shape or it gets sprayed on that surface, and that we have to learn under this topic. Shape of liquid drop on solid surface. Shape of liquid drop on solid surface. Shape of liquid drop on solid surface. So let's start with this. So suppose any surface is there, on that surface we have just put one drop of liquid. That drop either gets sprayed on the surface or it created perfect sphere or half hemisphere. It depends on the properties of solid and liquid in contact. So here, now let's start with your book. They have just drawn one diagram 2.20. Let's start with that diagram itself. So just they have taken this as a solid surface. So they have drawn it as a solid surface. So it is solid surface they have taken. They have kept here the drop of liquid and it has acquired a shape like this. Such is the shape of liquid drop. When we poured it on the solid surface, it acquired a shape like this. Now in this case, they have considered three surface tensions. So first, this is solid, this is liquid, okay, and this is air. So there are force of surface tension because of these three. The first one we can write here like this, one arrow I will draw it here, one another arrow I will draw it here, and another tangent I will draw it here. Okay, now let's give the name according to the book. So it is T1 to this side, this is T2 and this is T3. T1 is a surface tension between what? Air and solid. So air and solid is T1. T2 is a surface tension of the pair solid and liquid. Solid and liquid T2. Air and solid T1. And liquid and air it is T3. I will repeat once again. T1 is a surface tension between solid and air. T2 is a surface tension between liquid and solid. And T3 is a surface tension between liquid and air. That are the three surface tension they have taken. And from this diagram, we can equate the equation and we can write simple equation here. I will write it here. What they have written? T2 equal to T1 plus T3 cos of theta. Now how cos comes? Here there is no cos. We can resolve this T3 into two components like this. Here it is T3 cos theta and the perpendicular it is T3 sin theta. We can resolve these forces. So these are the perpendicular. So T3 cos theta we have taken, T2 equal to T3 cos theta plus T1. So we have written this equation. From this, just find out the value of T3. So just find out the value of cos theta, not T3. So we can say cos theta equal to T2 minus T1 divided by T3. T2 minus T1 divided by T3. So we get this equation, cos theta equal to T3 minus T1 divided by T3. Here this angle is nothing but theta, angle of contact. Tangentron, angle of contact, measure the inside the liquid, theta. So this cos theta we have find out T2 minus T1 divided by T3. Now here from this there are some conditions. That conditions we have to see. So let's start with the first condition. Let's start with the first condition that as you are given in your book. If T2 is greater than T2 is greater than T1. Sorry, if T2 is greater than T1 and T2 minus T1 and T2 minus T1 less than T3. Put this here. T2 is greater than T1, so numerator is positive, and this is less than T3, so it is fraction less than 1. Then cos theta is positive, whose value is less than 1. Then cos theta is positive. Okay, cos theta is positive. In that situation, what we get? The angle of contact is acute. We get this angle of contact as a acute. Theta would be acute angle. Acute angle if this condition gets satisfied, and that is the first application, first condition we have put in this equation. And this theta as shown in the figure is less than 90, it is said to be acute angle. Second condition, if Second condition would be there. If T2 is less than T1, exactly, if T2 is less than T1 and T2 is less than T1 and just remaining part T1 minus T2 less than T3. Here T1 minus T2 less than T3. Remember T2 minus T1 we have taken, here it is T1 minus T2 less than T3. So what does it means? In this equation T2 is less than T1. This is smaller than this. So numerator is negative and they are less than this, negative less than 1. Then we can say cos of theta is negative, and if it is negative, the theta is nothing but a obtuse angle greater than 90 degrees. Same thing they have given in your book, figure 2.20b. I have not drawn it here, so that is nothing but obtuse angle. Third condition they have mentioned. Let's start with third. If T2 minus T1 is T3, T2 minus T1 equal to T3, what will occur? See, T2 minus T1 is T3 divided by T3, it is 1. Cos theta equal to 1. Cos theta equal to 1. What is value of theta? Theta equal to 0. So angle of contact would be 0. Cos 0 is 1. And fourth condition, if T2 minus T1 is greater than T3, T2 minus T1 greater than T3 means this numerator is higher than denominator, resultant number is greater than 1, and that cos theta greater than 1, this is not possible. Why it is not possible? Because maximum value of cos theta is plus 1, minimum value is minus 1. So this condition is not suitable to us. Now this is nothing but how this shape of liquid drop on solid surface get formed, that we have seen. Now let's go to next topic of the same. So let's go next. Then I have just mentioned some factors which affect the angle of contact. So this angle of contact we have seen when it becomes acute, when it becomes obtuse, when it becomes 0, when it becomes 90 degrees. That part we have finished. Now what we have to see, what are the factors which are affecting the angle of contact. So let's start with this. What are the factors which are affecting the angle of contact? So the first, nature of liquid and solid in contact. If solid liquid pair is constant, then it can't affect. But if solid is different and liquid is different, suppose glass and water we have taken, instead of that, suppose iron and water we have taken, the solid gets changed, or iron and mercury we have taken, the solid, any of the pair get changed, then definitely the change in angle of contact. The first one, nature of liquid and solid in contact affect the angle of contact. Second, impurities. If some impurities are present in a liquid, it will change the angle of contact. For example, we have measured angle of contact is 0 for pure water and pure glass. We have seen pure water and pure glass. Third figure we have seen angle of contact is 0. If I have drawn some sugar in the water, sugar or salt in the water, it is impurity. Definitely, if you add these impurities in water, then there is change in angle of contact. If water is pure and if you add some impurity in a glass, still angle of contact get changed. That is nothing but second point they have mentioned. Third one, temperature of liquid. Any increase in temperature of liquid decreases the angle of contact. If temperature of liquid get increased, the angle of contact always decreases. For again next they have written in italic line, for given solid liquid surface, angle of contact is constant at that temperature. At some temperature, suppose at 40 degrees I have find out angle of contact, 40 degrees Celsius we have find out angle of contact theta equal to suppose 70 degree, and this is for one some solid liquid, glass and water. In between glass and water, it is not pure water is 0 na. So glass and kerosene you can take. So for this glass and kerosene, if you find out at 40 degree angle of contact is this, you go anywhere at this temperature, this angle of contact remains same. That is the meaning of that thing. But if you change the temperature 70 to 80, this gets changed. Definitely it is common sense. So this is nothing but properties. Again, after that there is one table in your book, table 2.2. In that table what they have done, they have given different solid liquid pair, their name and angle of contact for them. So pure water and clean glass, it is 0. Chloroform, clean glass 0, and so on. Kerosene with a clean glass 26 degree. Mercury with a clean glass is 140, and water with paraffin it is 107. Greater than 90, obtuse. Less than 90, acute. That you can know. So let's go next. Effect of impurities on impurity and temperature on surface tension. How the temperature and impurities affect the surface tension of the liquid, that we have to consider here. So let's start with first effect of impurities. So first, effect of impurities. So impurities affect the surface tension of material. Now there are two type of impurities. Three. There are not two. There are three type of impurities roughly we can say. So how impurities affect the surface tension? Effect of impurities on surface tension. I will in short. Effect of impurities on surface tension. Now there are three type of impurities. First, soluble. Soluble impurities. Soluble impurities means what? When we add that impurities, it gets dissolved completely in that liquid, soluble. Second is what? Insoluble. Insoluble impurities, these are the impurities, when we add them, they can't get dissolved in that liquid. Okay, that is second part. And third is what? Partially soluble. Partially soluble impurities. So partially soluble impurities means what? The impurities, when they get added to that liquid, some part get dissolved and some part remains undissolved. So these are the three type of impurities. Completely soluble impurities, insoluble, completely insoluble impurities, partially soluble impurities. Let's start with this, how they will affect the surface tension. Soluble impurities, just like I have told you, if we add some sugar or NaCl, sodium chloride, NaCl, sodium chloride, if we add to the water, it is seen that they are soluble in water. Sugar is soluble as well as NaCl, salt is also soluble in water. So if we add this soluble impurities like a sugar and NaCl in water, the surface tension of water, what will occur? Increases. Surface tension of water increases. So this soluble impurity increases the surface tension. Increases surface tension, get increase when soluble impurities are added to the liquid. Let's go to second part. Just we'll finish this third, then we'll go to second according to book. So if partially soluble impurities are added, an example of this is what? If we add detergent powder. If we add detergent powder in water, it is seen that detergent powder is not completely soluble, partially. Some part get dissolved, some part remains as a particle. So when partially soluble impurity, just like a detergent powder or soap, get added to the water, it is seen that the surface tension of water decreases. And this is the reason why we add the detergent powder or soap in water to clean our clothes. When we add this, it is seen that surface tension decreases, so the water can reach to small fibers of the cloth. The water can reach to that small fiber of the cloth, and that cloth small fiber can be cleaned and stain can be removed, because water can reach to small fibers, because surface tension decreases by addition of detergent powder, and that is nothing but a partially soluble impurity. When we add insoluble impurities, just like they have used in your book the name as insoluble impurities, they have just taken the two type of liquid they have mentioned. This is seen that insoluble impurities added into water, surface tension decreases, and such type of surface tension get decreased in this case. So here, when insoluble impurity added, again the surface tension decreases. And one of the best example for this, they have taken mercury. When we have kept mercury open in the air, it is seen that some dust particle goes in that mercury. Dust particle goes in that mercury, and when we put the mercury, suppose this plate, I have taken glass plate. When we put a small drop of mercury or small piece, very small piece of mercury, it will acquire perfect spherical shape. Drop stand like this. If it is made up of mercury drop, it stand like this, pure mercury drop. But when some dust particle goes in this, then what will occur? So this is pure. It is a pure mercury we have added. Now we have taken some insoluble impurity like a dust. Dust goes, and when we drop it, it is seen that it goes like this. It never stand exactly spherical. This would be the shape of mercury drop. Ideally, it should be like this. It goes like this means what? See, here there is a gap like this. This part is a gap, but here there is no such type of gap. It gets sprayed on this. Why? Because impurity comes here. And why When the dust get added, dust as an impurity, its surface tension decreases. That's why this shape gets destroyed, it gets spread like this. So that is nothing but a effect of impurities on this surface tension, that we have seen how the impurity affect the surface tension. So these are the three parts we have seen. Apart from this, one more part is remaining, how the temperature affect the surface tension of the liquid. Here the second part of the same, effect of temperature. So let's go to the effect of temperature on surface tension. So how the temperature affect the surface tension, that we have to see under this. It is seen that generally as temperature increases, surface tension is always decreases. Most of the solid liquid pairs, it is seen that temperature increases, surface tension is always decreases. In your book, they have taken an example. It is suggested that new cotton fabric, see, when we go to buy the cloths, when we buy the cloth first, just like a jeans or cotton cloths we have bought, initially they have just given notice on that first wash the cloth first in cold water, don't use a hot water. What will occur when we use hot water? If we use a hot water, it is seen that surface tension decreases, and that due to that decrease in surface temperature, water get reached to small fiber, and that may get change the color of your cloths, cotton cloths color first washing. That's why they recommended that initially for first washing you wash this with the cold water. Okay, if you use a cold water, temperature is less. Then if temperature is less, surface tension increases. It can't go to that fiber and it can't remove the color of your cloths. That is the example they have given in this. So apart from this, hot water is used to remove the tough stains. Suppose cloth is, we get some blot on our cloth, a lot of dust is there, some blots are there on our cloth, then preferably at your home we are using hot water to wash such type of cloth, because if you use a hot water, the surface tension decreases and automatically water reaches to fiber and clean that, the hard stain or tough stain can be cleaned. In case of molten copper and cadmium, there are some exceptional cases. Everywhere there are exceptional cases. Here also the two exceptional cases, that are nothing but what? Copper and molten copper, that is in liquid form, molten copper and cadmium. In their case only, as temperature increases, surface tension also increases. All remaining cases, as temperature increases, surface tension always decreases. So you must put this point in your mind, and you must remember this point always, that surface tension generally decreases with increase in temperature, except molten copper and cadmium. In that case are the two exceptional cases. For them, as temperature increases, surface tension also increases. So the surface tension of the liquid becomes zero at certain temperature, and that temperatures are said to be critical temperature. At certain temperature, so only certain temperature, certain value of temperature, it is possible to make a surface tension zero, and that temperatures are said to be critical temperature. So this is nothing but about this topic. Next topic we'll see excess of pressure across a free surface of the liquid, and explanation of a drop and bubble, how drop and bubbles get formed with a capillary action, that we'll see in next video. So watch my video and just see, same topic you have to read from a book. Still, if you have the problem, you can contact. Thank you.